Similar to yesterday, but we're going to create our own tree diagrams today to help us understand what's going on. We have two different conditional probability formulas that we have. It says for any two events A and B, the probability of B occurring given that A has occurred is the probability of B given A. So that is equal to the probability of A and B happening over the probability that A had already happened. It's pretty simple, right? No? You want an example of that? Okay, so let's go with, if I write this out in words, 20% of the people play football. 30% of the people play soccer. And 5% play both. Is that easy to understand that 20% of people play soccer or football, 30% play soccer, and 5% play both? So if I want the probability that a soccer player plays football, could you calculate that? The probability that a soccer player plays football. What do they have to be? They have to be a soccer player. So they have to be a soccer player. That's our given statement. They have to be a soccer player. Now, what do you call it if they are a soccer player that plays football? They're both. So what's the probability of both? 5%. So that's going to be both over soccer. So the probability of A and B, that's going to be our both quantity. That's 5. Over the probability they play soccer, that's 30. So whatever 5 divided by 30 is. That would be the percentage that a soccer player plays football. That's not terrible, right? It's getting past the language. Most people will try and put football on the bottom instead of soccer. But they have to be a soccer player to play football. So that's the probability that given they are a soccer player, they play football. That's this one up here. This one says, like, if A and B are dependent events, then A and B is equal to the probability of A times the probability of B given A. That would be like, how would you say that? I don't know if my numbers would work. We'll get to that one. That would be like, this second example would look like this. 50% of people took Form B, and 25% of people that took Form B passed. Huh? So, does your passing percentage depend on you taking Form B? Yeah, because 25% of people that took Form B passed. This would just be a straight up, the probability that you took Form B times the probability you took Form B and passed. So you do 0.5 times 0.25 and you get your deal. So the thing we're learning today is, are you going to multiply the probabilities together or are you going to divide them? That's the big overarching goal. When do I multiply and when do I divide? All right. Let's just try it. And this stuff can be super confusing because there's so much to read. In a study designed to test the effectiveness of a new drug, half the volunteers received the drug, The other half of the volunteers received the placebo. You know what a placebo is? It's like a fake drug. It's like a sugar pill. Like you think you're taking the real drug, but you're not really taking it. All right? And that's a tablet or pill containing no medication. Now, the probability that a volunteer received the drug and got well was 45%. What is the probability of someone getting well given they received the drug? Let me read it again. Or maybe write some stuff down. Okay, or what would we write down that would help us make this make sense? Anything? Well, the first thing says, in a study to test the effectiveness of a drug, half the people got the drug, half the people didn't. So we can draw these tree diagrams. So we got half the people took the drug and half the people took the placebo. So to delineate or explain what's going on, 50% of the people got the drug and 50% of the people got the placebo. Does that make sense? Now, the probability of a volunteer receiving the drug and getting well was 45%. Receiving the drug and getting well. So if you take the drug, you can get well or you cannot get well. Same thing with the placebo. You could get well or not get well. This is a large mistake that I made last year. Remember when we talked about what is the probability of drawing a jack and a king? What do we do when it says and? We're multiplying. So and means multiplication. So if I do this 50% times some percentage, the probability of someone getting the drug and getting well is 45%. Well, it's 50 times something equals 45. Does that make sense? Well, if 45% of the people got well, how many people didn't get well? 5%. Does that make sense that this adds up to a total of 50% of our people? Cierto or no falso? Does that make sense? Maybe? Maybe math happened? Let me double check so I don't screw it up. Yes. What's that?
Are you sure?
I'm positive, absolutely positive. So, if you go back to that and word, the probability of them doing this and this equals how much? 45. So, the probability of doing the drugs and getting well equals 45%. Don't we know what the probability of doing drugs is? 50%. Times. Do we know what the probability of people getting well is? We don't. That's going to be our question mark. So how do we solve for that question mark? If it's 0.5 times something equals 0.45, how do we get that times that something, that missing part? We have 0.5 times something equals 0.45. How do we solve for that? Divide both sides by 0.5, which is 90%.
90%.
So The probability that someone got well, given they received the drug, was 90%.
So they get the drug.
That number goes right here. 90% of the people who took the drugs got well. Yeah?
Yeah.
Use 2.45 over 0.5.
That's what we did.
Yeah, but from the beginning.
Yes.
And not do all that?
Yes. Absolutely. Because that is this formula right here. How many people took the drugs and got well? Out of how many people took the drugs? Is that clarified a little bit? So this is the probability that A and B happened. 45% took the drugs and got better. Given how many people took the drugs? 50%. So that's if you use that probability of drugs and getting well, given, remember this is always our bottom number, how many people took the drugs. Is that easier than doing a tree diagram? I think that's not bad, right? No? You hate it? It sucks? Trust me, I know this sucks. Look at how much math that I did this morning to prepare for this. Is it? I know it's confusing, but is it impossible? Okay, that's the first example. All right, we're one down. Can we go? Can we keep going? Can we struggle through this together?
Yeah.
All 8 of us? For the internet to hear? Do you have to do all this?
No.
No. But isn't it fun?
No, it's not.
Can I add one other layer? Please?
Yes.
Please?
Yes.
Look, if 90% of the people got well, how many people didn't get well? 10%. And 50% times 10% is 5%. So this gives us 100% of the people that took the drugs. Kind of cool. No? All right.
Easy, but
All right.
we can do it.
In a survey, 45% of people own a dog. 27% are cat owners. 12% own both, a cat and a dog. What is the probability that a dog owner also owns a cat? We'll just look at this one right here. What is the probability that a dog owner also owns a cat? Did I not put that in your notes? Did you write it down somewhere? Is that this one or this one? Top one or the bottom?
Where's the top one? It's the same. Wait, it's like the same thing that you showed us for the first one.
Does the given statement indicate what you're supposed to be doing? There's a hidden given statement in there. Okay. Are the two events dependent? Does the probability that you own a cat and a dog depend on the probability you own a dog? Yeah, those two events are dependent. So this is going to be A and B. So it's going to be the probability that the first event happened given the second event happened. Right? Or is that the top one? Now you got me confused.
You got me confused.
What do you think, Harry?
Does it always end up as the top one? Kind of.
I'm trying to look back at the first one that we did.
The first
Like
one, the first
football,
example.
Soccer and golf.
Okay.
And I feel probability on this one.
You think it's this one?
I think so.
For any two events, the probability of B occurring given that A has occurred. So what is the probability that you own a cat given that you own a dog? Or is it this one? Okay, so what we're looking at here, what is the probability that you are a dog owner that owns a cat? So this would be the probability that you're a dog and cat owner over the probability that you're a... This is the both. This is the both. This is you own a cat and a dog. This is your both percentage. That should always go on top. Usually your both, is it dog or is it cat? It's dog. Because given you are a dog owner, what is the probability you also own a cat? So how many people own a cat and a dog? 12%. Over how many people just own a dog? 40.45. So in the math calculator, that looks like 0.12 over 0.45. About 26.66%.
Why would it be 0.66? You own like
8.67. That would be fine. Huh?
So what do you own a 0.66 of a cat?
Well, it's a ratio. You can't. It's not like 0.66 of a dog. It's 26.66% of the people.
Did you round it to 27?
I prefer 2 decimals. All right. What is the conditional probability that a cat owner owns a dog? So this is still the probability of you're a cat, a dog, and cat owner over the probability that now you're a cat person. It says, what is the probability that a cat owner owns a dog? So the probability of both is still your 0.12, but the probability that you're a cat owner is 0.27.
0.4444.
So 44.44%. I know that's right, but I just checked the math. They put 26.7%.
Who's the little line?
What? That little line means given. So, what is the probability that you're a female given you're a freshman? So you can only look at freshmen. How many people are freshmen? That's the bottom. How many people are females that are freshmen? Are. How many people are females? So it's 5 of 8. All right. Here's the tree diagrams. I like these. These are fun for me. These are in your notes. It says tree diagram shows the percent of boys and girls in 10th grade. Sorry. And whether they joined the government club or not. So can we fill in some blanks here?
Yeah.
If there's 55% of the girls, how many have to be boys? 45. That accounts for 100% of the people in the survey. What'd you do? Oh, over here? So if this is 15%, what does this number have to be? 85. Because this is saying 15% of the boys joined the club, 85 did not. Does that account for 100% of the boys? Yes. 80% of the girls didn't join. How many girls did? 20%. So, how many are boys and join the club? What? How many are boys? What is the probability that it is a boy and he joined the club? It's not a division now. What does and mean? So the probability that you're a boy and how many boys join the club. So this is an and statement. Probability that you're a boy and you join the club is 0.45 times 0.15. So that's 6.75%. What's the probability that you're a boy and did not join the club? So what's 0.45 times 0.85? $38.25. Okay. Does that make sense at all? Why? But why? There should be an absolute reason that it makes sense.
There's like we're trying to find a percentage of the amount.
I just need to read that.
What's that?
I just need to know.
Math, right? Yeah. I didn't know when to multiply and when to divide. That was the whole idea today. Somebody add 6.75 and 38.25 together for me. 45%. Why does that sound so familiar?
We've talked to that.
Right? Or no? So, if I have 6.75% in the club and 38.25% out of the club, does it account for 45% of the boys total? Okay, now what if I did something super crazy like what is the probability that you join the club given you're a boy? What is the probability you join the club? What is the probability? I'm looking for what is the probability that you join the club given that you're a boy? Okay, the probability that you join the club given your boys, this top number is the number of boys that are in the club. Boys and club. What number is that? How many? What's the percentage of boys? What is that? 6.75 divided by 45. Ha! Does it make sense? So what we've just discovered is this is your and the probability of A and B, and this is over here is the probability of B given A. So this is your given statement, this is your given probability, this is your and probability. So let's keep mathing. If 55% are girls and 20% join the club, what is the probability that it is a girl and she is in the club? 11%. What's the probability that it is a girl and she did not join the club?
Or 44%.
So if I add all these numbers together, it should give me 100% of the people accounted for in the survey. So what is the probability that you join the club given you're a girl? What's the probability that you join the club given you're a girl? Probability that you join the club given you're a girl, that's this probability right here. Is it kind of clicking? Is the tree, you like the tree diagram more now? Do you want to draw them all the time? Probably not. So there's a couple different ways to pursue that. This is going to be your A and B, these percentages over here. And this is going to be your given statements over here, your probability of B given A. Right. Oh, here we go. Let's just answer some questions. What is the probability of a boy joining the government club?
6.75.
Give me these numbers. What was this? 6.75?
38.
38.25. 11.44.
So what is the probability of a boy joining the government club?
6.75%.
One more time?
6.75.
Yeah, this one right here. Is that okay? Probability that your boy and join the government club is 6.75%. What is the probability of randomly choosing a student who joined the government club? So, one more time?
50.75.
How'd you get that?
Or, that was the wrong one. Never mind.
So this is the probability of randomly choosing any student that joined the club. This percentage joined the club, and this percentage joined the club. So how many total people, or what is the total percentage of people joining the club?
17.75.
17.75%. So if you look at, let's say there's 100 people in the survey. If there's 100 people in the survey, 45 boys, 55 girls. Well, there's 6.75 boys in the club, and there's 11 girls in the club, so you get 17.75 people.
Just chop off a couple limbs.
Yeah, I mean, like we're talking, like, you have to make them like nice numbers for it to make it really happen. Okay. In a survey, half the students walk to school, the other half take the bus. Out of all the students that were surveyed, 35% took the bus to school and played sports. I'm sorry, 35% took the bus to school and played sports. 20% walked to school and played sports. What is the probability that you play sports given you take the bus? Is there any hope? Have I done enough? Huh? What are you saying? 35%? Okay, now how are we going to do this? Are you going to draw a tree diagram, or are you just going to like formula math it? Formula math it? Maybe? Remember what this means, given? This means that the probability that you take the bus is on the bottom. So what is the probability that you took the bus? Hold on.
35%.
Or 50.
No, it's
50, right?
50.
Because half the students walk to school, half the students take the bus. So the probability that you take the bus is 50%. Hope this mic doesn't pick up whispers because I'm just cursing myself quietly over here. So what's the top number?
35.
took the bus to play sports, right?
Yeah.
Because it'd have to be, if it's given they take the bus, how many take the bus and play sports? So this would be the probability of bus and sports, which would be, what's 0.35 divided by 0.5? 70%.
70%.
I got it. Can I show you what I did? Walk, bus. 50% walk, 50% take the bus. And we have sports and no sports. Sports and no sports. It says that 35% of the people that took the bus, 35% took the bus and play sports. Where does that go? If you took the bus and play sports, does that go right here or does that go over here? This over here. And does it make sense that $50 times 0.7 equals 0.35? So 70% of 50 is 0.35. Now we can start more mathing. If 70% played sports, how many didn't play sports? 30%. So that counts for 100% of the bus riders. So 50 times 30 is 15%. That gives me 50% of my bus riders. What's the probability that you play sports given you walk? 20% of the people walked to school and played sports. This is 20%. And this would be 30%. That accounts for 50% of the walkers.
Yeah.
So if you look at the tree diagram to figure out how many people walked, play sports given they walked, it would be 20% over 50%, which is 40%. 40% of the walkers played sports. 60% of the walkers did not play sports. So doing this is definitely the most rapid way to get to the answer. But sometimes drawing a tree diagram makes it make more sense. Isn't this fun?
So much fun.
You love this for yourself?
No.
I love it for you. What is the probability that someone who walks to school does not play sports?
60%.
Wait.
30?
30%.
What? Don't quit. Is it 30 or 60?
60.
No, 60% of the people that walked don't play sports. What is the probability that someone who walks to school does not play sports? The 60% is what is the probability that you do not play sports given you walk to school? Versus what is the probability that you walk to school and do not play sports? Well, fuck, now I'm confused. Is it 60? Is that a given statement? You save a banger for the last one? Any info back here? No? Good? Tapped out? Let's see if the book has the answer.
I hope it does.
I'm gonna go with, what are you going with, Harry?
60.
You're going with 60?
Yeah.
What is the probability that someone, oh yeah, it has to be 60. Someone who walks to school does not play sports.
That was right. Let's see.
How many people that walk to school play sports? 40%. So how many don't play sports? 60%. This is that given statement. Bad Baker. That's a given statement. All right, that's like, what is the number of dog walkers who go and cats, right? Your brain's marshmallows right now? Let's keep going. In the senior class, 24% of the students play softball, 32% of the students play field hockey, and 14% play both. What is the probability that a softball player also plays field hockey? This is going to be your probability that you are a field hockey and a softball player over the probability that a softball player plays field hockey. Softball. So the probability that you play both is 0.14, and the probability that you play softball is 0.24. That's literally just what we were arguing about. What is the probability that someone who walks to school does not play sports? So they have to walk to school, given they're a school walker. Anybody do that? And what is the probability that a field hockey player also plays softball? One more time.
43.75.
Is that better? I think when you see, here's the indicator. When you see the word both, you gotta think a division. Because on your test, it's like 48% people bought DVDs, 75% people bought Blu-rays. How many people, or 25% bought both? How many people who bought a Blu-ray bought a DVD player? So it's like the both over the percentage of the first one. This was off your homework. You all want to do a homework question together, or you just want to like kill it? Are you done? Is anybody tapped out? Again, it's not for a grade, but it should completely solidify your confidence in this. I went for at a recent swim meet, half the swimmers experienced an improvement in their race over the previous swim meet. And they're up here on your, see all that stuff we talked about in class? They're up here on your stuff. The probability of a swim club member experiencing an improvement in their race and training the week before was 30%. So, based on the information they just gave us, at a recent swim meet, half the club members experienced an improvement in their race. What is the percentage of people that experienced an improvement? Up here. How do I break this improved versus did not improve? 50-50. 50% of the people got faster. 50% of the people did not get faster. The only other piece that they give us is the probability of a swimmer experiencing an improvement and training was what? Experiencing an improvement and training. It's 30%. Does that go here or does that go here? It goes over here. Because this is improved and trained was 30%. So if 30% improved and trained, how many improved and did not train? 20%. That has to add up to our 50% total. Now it says the question says, what is the probability that a swimmer trained given his or her race time improved?
So,
Ah.
30 over 50 or 30.
Huh?
If it improved given that they trained,
What is the probability that they trained given they improved? So probability that they trained given they improved is literally the probability that they trained and improved over the probability that they improved. What is it? 60%. Okay, look, if you guys are freaking out over that, the probability that they improved and they trained equals how much? 30%. So the probability that they improved times the probability that they trained equals, so you can divide it by 0.5 and it gives you that same. Training and improving is 30%, improving is 50%. That's how you get that 60%. Because A times B is 30 and A over B is 30 over 50. So look, if 60% improved, how many did not improve? 40. That is 100% of people. If 60% trained and 40% didn't train, that's 100% of people that improved. Okay, the next question goes to the bottom. It says the probability that a swimmer did not experience improvement. So now we're down here at the bottom of the tree. In his or her race and trained the week before. So did not improve and trained is 10%. So not trained would be 40%. That gives us a total of 50% of people that did not improve. So it wants to know, what is the probability that you trained given you did not improve so what is the probability that you did not improve and trained? 10 over the probability that you did not improve, 50, which gives you 20%. So the probability that you trained given you did not improve is 20%. What is this number over here? 80%. The probability that you did not train given you did not improve is 80%. It's definitely not easy. It's not easy. Number 3 is going to be a multiply problem. Just people that took Form B times the number of people that passed. I'll leave this answer key up here. Feel free to take a picture of it. Let me highlight all my answers so you can at least know what you're working towards. That'd be better than just shooting blindly through this assignment and seeing if you're right, if you want to work on it. Tomorrow we'll work on the review, and then Monday we'll take the test. Is there anything else y'all want to go through, like question-wise, before I kill the recording, or do you think you're just over it?
It's over.
Just over it?
Yeah.